We are going to look at an extended mole train problem. And let's take a look. This is number 10 on page 4 of homework packet 8. What mass of copper will be required to completely replace the silver from 500 milliliters of a 0.30 molarity solution of silver nitrate? Okay, so let's just figure out what's being asked here. It says, what mass of copper? So I might write here by the copper, I might put a question mark and I might put a G for grams. Whoops, that's not a question mark. Let's try that, and then a G for grams. And then the second thing I'm asked for, it says 500 milliliters. And it also says 0.30 molar. Both of those things are describing, or 0.30 molarity, AgNO3. So it looks like I'm comparing two reactants. Can I compare just two reactants in an equation? Yes, you can compare amount of cheese to amount of bread in a sandwich, amount of scoops to amount of cones in an ice cream treat, and amount of copper to amount of silver nitrate here. So it looks like we know the liters and molarity. Perhaps we can use that to find the moles of this, know the moles of the copper, and know the grams of the copper. Okay, but I think we can get a little assistance in doing that, and we are going to look at our mole train. So we kind of have this mole train that we developed before. I know I got a little writing in there to block that, but I think it's okay, where we talked about going from moles to liters through molarity. Okay, so that was the extension that we have, okay, or liters to moles through molarity. But now we're dealing with two substances, so we need a mirror image of this. So in order to do that, make this a little smaller. Okay, I'm going to bring this down, maybe even a little bit smaller. And now we are going to actually try to look at this whole piece here, an extended mole train with a mirror image, just like our other mole train, but we have this moles connected to liters and moles connected to liters right here. Make this a little bigger and let's see how this fits into our problem that we're going to be doing. So it looks like we're going to try to, what we know, I'm going to put this on the bottom. I'm going to write in AgNO3 for the bottom part of the train. And what do we know about AgNO3? We do know I think we know the liters. So I'm going to put a little asterisk there because we know that. So I'm going to do that. We also know the molarity. So I'm going to know that right there too. And so if I know the liters and molarity, and we're asked to find grams, but it's not grams of silver nitrate, we're supposed to find the grams of copper. So I'm going to put a Cu up here. I'm going to put an asterisk right here. So I'm going to end up taking my liters, which I think I said I had, what, 500 liters or 500 milliliters, which would be 0.5 liters. And it looks like I'm going to have to times it by my molarity right here, which is 0.3 molarity to get to moles. Then I'm going to have to go through my balanced equation ratio, which I don't know, is it 2/1 or 1/2? I don't remember, but we'll get there. And then I'm going to have to multiply it by the molar mass of Cu. So that's my strategy here. Liters times molarity to get to moles, go through my mole ratio here, and then multiply by the molar mass of Cu to get to grams. So that's my roadmap for following this problem, here to here to here. So let's go back to that and take a look and solve this. So make this a little bigger so we can see it again, and move this out of the way. I think we got enough right here. I get rid of a couple things, these little things here that we did, and we're kind of back to where we started. So I'm going to write what I know, but I'm going to convert the 500 milliliters to liters, and I'm going to call that 0.500 liters. And I'm going to say I'm going to say what substance it is, because I'm going to be switching trains right here. So I'm going to say 0.500 liters AgNO3. And then I'm going to times that by the molarity. And the molarity is 0.3. And that's going to be 0.30. And I'm going to say moles of AgNO3. Whoops. We'll put a little 3 here. AgNO3. Not very close. Try that again. So we got 0.30 moles of AgNO3. Good enough. Over 1 liter. That's molarity. 0.30 moles over 1 liter. And I'm going to call that AgNO3. That'll write in here. Okay, so that's my first step. Now my next step is I got to go from moles of AgNO3 to moles of Cu. So I'm going to put a little times here. I'm going to draw a line here. I'm going to put moles of AgNO3 here. Scooch this a little closer here. Moles AgNO3 here. I'm going to put moles of Cu on top. And the deal is I'm coming from moles of AgNO3, so that 2 goes on the bottom. And I'm going 2 moles of Cu. That's my unknown, so that goes on top. So essentially, all that big deal is telling me to multiply by 1/2. Okay, that gets me to moles of Cu, but I want grams of Cu. So what I'm going to do is put 1 mole of Cu on the bottom. And then I'm going to put the molar mass of Cu on the top, which is, if I round it to just 2 figures, it's 64 grams of Cu. And I think I'm going to be done. I'll say equal sign, and I'm going to say 0.5 times 0.3 divided by 2 times 64. And I believe I get 4.8 grams of Cu. So that is following the mole train. Liters times molarity gets me to moles. Go through my mole ratio times 1/2 gets me to moles of Cu, and then times the molar mass gets me to grams of Cu. Let's look at another method using an adapted box method, and just another way to do the same problem. All right, so here's what I'm going to do here is I'm going to kind of get rid of this. I'm going to look at this problem, and I'm going to say, I want to find the mass of copper. So this is my destination. I know the liters and the molarity of AgNO3. I don't really know the mass, the molar mass of the moles, but if I know the molarity and the liters, I can figure out moles. So I'm going to go to this box right here, and I'm going to plug in 500 milliliter, or the molarity is 0.30. So I'm going to take 0.30 molarity here, say 0.30, and then I'm going to times that by the number of liters. Now remember, 500 milliliters is move my decimal 1, 2, 3 spots, it's going to be 0.5 liters. So make sure to do that part. And I'm going to say times 0.500 liters, and that's going to equal 0.3 times 0.5 is going to be 0.15 moles. And what are we talking about? AgNO3. So, moles of AgNO3. I'm going to put 0.15 here. Okay. So that was like the first step when we were following our mole train. The next step is to go from moles of AgNO3 to moles of Cu. And looking at that, I'm going to look at these two numbers right here, the 1 and the 2, and I'm going to go from 0.15. I'm going from 2 to 1, so my number is going to get smaller, so I'm going to divide by 2. And when I divide by 2, I get 0.075. And then I got to find the molar mass of Cu. I look at the periodic table, which is 64. And what happens going from moles through molar mass to mass, we multiply. And if I multiply 0.075 times 64, I get 4.8 grams. And I would come to my answer that way. So either following the mole train or an adjusted mole box, you can solve this. Notice I didn't have to mess with the products at all. And again, that first step here, I knew the molarity, I knew the liters, I used that to get moles. Now I thought out of the box, now I got into the box, and then I just go the rest of the way to solve that. So those are two ways to do an extended mole train problem. Thanks for watching.